Last chapter, chapter 5. So this first one is like a simplifying exponent rule sort of question. So we've got 3x to the 0, and then that's squared, and then times 2x to the 4th. All right, so what you're going to do is the first thing you need to do is square everything in the first term. So you kind of distribute it. So you take the 3 and you square it. So that gives you 9, and then you take the x to the 0 and you square it, so you multiply those exponents together. So 0 times 2 still gives you 0. All right, and then times 2x to the 4th. Okay, so here's how these properties work. You multiply the numbers together, so 9 times 2 gives you 18, and then x to the 0 times x to the 4th. When you multiply two bases like that together, what you do is you add their exponents. So 0 plus 4 still gives you 4. Another way is we could have kind of cut this right from the beginning, because x to the 0 is always just 1. So really, from the beginning, you were just taking a 3 and squaring it, which of course is just 9. So 18x to the 4th is letter D. Number 2, simplify this expression right here. So more of these exponent rules that we're going to be playing around with. Okay, so what we want to do is kind of work on each piece individually. So let's start with numbers. So big quotient here. So 3 over 15, we can reduce that down. They both have a common factor of 3. So 3 divided by 3 leaves us with 1. 15 divided by 3 leaves us with 5. All right, next let's worry about the y's. Okay, so y's, I've got 2 copies of y in the numerator. I have 5 copies of y in the denominator. So there's a couple different ways you could do this. You could subtract, which is kind of how this property works. If you have y in the numerator, y in the denominator, you subtract 2 minus 5. So 2 minus 5 leaves us with the power of negative 3. And then this is the only z that we have anyways. So last thing we need to do is y to the negative 3rd. Any negative exponent that you have gets flipped down to the other side of the fraction. So all I have left is a z. I don't really need to write the 1. You can if you want to. And I have a 5 down here, and then the y to the 3rd gets flipped down. One thing you could have done from this step is you could have kind of canceled 2 copies of y. So if I cancel these 2 copies, if I get rid of 2 of these copies, I'm left with 3. So that's kind of an alternate way, and of course it leaves you with the same answer. So letter F on the multiple choice. Okay, Shen is simplifying this expression. Okay, which of the following is the correct product? So we are going to FOIL this out. It's like super foiling. So we start with 3x to the 4th, multiply that by everything. So add these exponents, 4 and 3. So we get 3x to the 7th. Then multiply this by this. So 3 times 2 is negative 6, negative 2. And then x to the 4th times x squared is x to the 6th. Then multiply this times a negative 1. It just becomes a negative 3x to the 4th. All right, so that's kind of the first round with this. Then we multiply this one times everything. So 4, and then x to the 5th. Then this times this. So the coefficient is a negative 8, and then I have x to the 4th. And then times negative 1, nice and easy again, just a negative 4x squared. So what we need to do is combine like terms. We really don't have many. We just have these 2 actually, are the only like terms. So I have 3x to the 7th, and then negative 6x to the 6th. 4x to the 5th, I combine these 2 up and I get a negative 11 for my coefficient. And then minus 4x squared. So, whew, that's a lot to match up. Okay, let's see. It looks like it matches B. Okay, simplify this. Oh, this one's going to be a breeze compared to that last one. Oops, this should be minus. Sorry about that. 9. Okay, so simplifying that up, you're combining up like terms, you're adding them all together. So 5m plus 4m gives us 9m, and then a negative 9, sorry about that negative sign, negative 9 plus positive 2 leaves us with a negative 7. Okay, so not really much to that one, just kind of combining like terms. That leaves us with h. Be careful with letter J, that kind of involves some weird multiplying, not even foiling. We're not doing any multiplying here. Make sure you're paying attention to the sign in the middle. Okay, simplify this. This is like a distributing sort of thing. Okay, so we've got this 3x on the outside. You're going to distribute it to all the other terms. So multiply here. So we get 6x to the 3rd. Distribute this here, and then minus 3xy. So that one wasn't so bad either. That matches with letter D. Okay, number 6, simplify this up. Okay, so we have a lot of different options here. We could do long division, we could do synthetic division, we could even do like some factoring and canceling sort of thing. Let me show you the factoring way. So if we take this right here and factor it down, we get x minus 7, x plus 5. That's what multiplies to negative 35 and adds to negative 2. Then if I divide it by x plus 5, what we actually end up doing is we just cancel out this common x plus 5, and so I'm left with x minus 7. That's one way to do it. I could also do synthetic, because I know we're pretty good at synthetic by now. So I could take 1x squared minus 2x minus 35. Then I set up my little box. Now this is different from synthetic substitution. If I'm dividing by a whole factor, remember the way this works is I actually put the opposite of the factor inside the box. Okay, so I bring down this 1. That's always my first step. Then I multiply 1 times the negative 5, and I put that right here. Then I add these two together, and I get negative 7. Then I multiply negative 7 times negative 5, and it gives me a positive 35. Then it leaves me with a remainder of 0. So since this was an x squared, when I use these as my coefficients, I drop down to just an x. So I have a 1x, and then minus 7 with no remainder. So I get the same answer either way. It depends really on what you think is the easiest thing. But either way, that's letter H. Oh, you could also do polynomial long division, but I think that there are very few of us that prefer that to synthetic division. So we'll stick with the synthetic for now. Number 7, which represents the correct synthetic division? So I'm going to set it up for you guys, and then we'll compare it to the options that we have. So we've got a 1x squared, negative 4x, plus 7. And because you're dividing by an x minus 2, like I said with the last one, when you're dividing by a factor like that, you put the opposite of the factor in the box. Okay, so automatically that eliminates A and C because they put a negative 2 in the box. So we bring down 1, always the first step. Multiply 1 times 2, it's just 2. And then add this column together, and I get negative 2. Multiply negative 2 times 2, and I get negative 4. And then add this column together, and I get 3. All right, so if you're looking at the options, mine looks exactly like letter D. There was a quick mistake with a negative in example B. You see like 7 lined right up underneath it should be a negative 4, not a positive 4. Number 8, factor completely. So getting lots of factoring practice recently. Okay, so factoring that completely. We've got 2 binomials here. The beginning is always pretty easy. To get an m squared, we've got an m here and an m here. Multiply those out. And then I'm going to have numbers in these spots. I need those numbers to multiply to give me 14. So it should be 2 factors of 14. And then when I add up my outside and inside terms, I need to get a 9m. So these two numbers have to multiply to 14 and add to 9. That would be a positive 7 and a positive 2. It's probably pretty easy when you were looking at some multiple choice options in front of you. But it's letter G. Number 9, simplify this. Okay, so this is actually really, really similar to number 6. They intend for you to simplify this by factoring, but you could absolutely do long division or synthetic division or, yeah, I guess that would be it. You could factor or you could do that. I'm going to factor just because, you know, we could always use some factoring practice, and I think we've done a lot of synthetic division recently. So factor the numerator out. To get a t squared, we've got our t and t. These terms, these numbers, I'm supposed to multiply to a negative 6. So first of all, if I'm multiplying to something negative, I know I'm going to have one negative and one positive. So that's kind of a starting point. And then when I add up my outside and inside terms, I'm supposed to get a positive t. So I'm going to have a positive 3 right here and a negative 2 over t minus 2. So this works just like number 6 did, the first way that I showed you. T minus 2 over t minus 2 is just 1. So it's like I have 1 times t plus 3. Which of course is just t plus 3. It's letter D. Okay, number 10. They want p of negative 3 if p of x equals 4 minus x. So this is a very simple example, but basically just kind of recapping you on how the function notation works. Function notation says p of x equals, and then you've got an x here. If you do p of negative 3, it means they want you to replace the x with a negative 3. So 4 minus, and then we plug in our negative 3. So of course that becomes plus a positive, and that just leaves us with 7, which is letter J. Okay, number 11 is right here on the page. So it says state the number of real zeros. Real zeros are the same as roots. They're the same as x-intercepts, all sorts of other different words. Here's our x-axis right here. That graph does all sorts of things above the x-axis, but it doesn't ever cross it. So we actually don't have any real zeros at all. That would be letter A. 0. Okay, flip the page here. Number 12, determine the values between which. Okay, so this one I need to show you as well. So here's our graph. So a real zero, so same thing, same definition as before. Our real zero is right here. We just have one of them. It's my x-intercept. It doesn't cross right through one of the values on the x-axis. Here's negative 1, and it's in between negative 1 and negative 2. All right, so that would be letter H. Okay, 13, estimate the x-coordinate. Oh, we're still going on this graph. Estimate the x-coordinate at which a relative minimum occurs. So relative minimums and maximums, remember, are those little valleys and hills on the graph. So like this right here would be a relative maximum because it's bigger than everything around it. This right here would be a relative minimum. It's a little valley. It's lower than everything around it. So right here, there's a relative minimum. Estimate the x-coordinate. Coordinate looks right around 2. All right, so that would be letter B. Okay, 14, write this expression in quadratic form. So this is something that we really haven't done since like the first day of notes, so I wouldn't expect you to do this on the final, but since it's here, we might as well do it. So the middle term, we're treating x squared as kind of our normal variable, and then this thing right here is supposed to be the middle term squared. So what you do is you write the x squared in parentheses, and then you square it. Like I said, not really something that I'm expecting you to do. We only did it for one day when we did the notes. But either way, this matches up with letter F. I would expect you to be able to do something more like 15. So whether you do like the weird substitution or not, you should be able to solve this one. You saw something just like it on your second chapter 5 quiz. So this one we're going to solve by factoring. So you start by setting up your factors, setting them equal to 0. So just like factoring some of the other ones we've seen, here and here they're supposed to multiply to x to the 4th. So I'm used to just seeing x and x, but this is actually going to be x squared, x squared. Then these two numbers are supposed to multiply to 36, but then when I add up my middle terms together, I'm supposed to get a negative 13. So if I'm multiplying to something positive and adding to something negative, I know for sure that they're both going to be negative. Okay, and then to multiply to 36 and add to 13, it's going to be 9 and 4. Okay, so now two options here. Two options. We can either set these terms equal to 0 right now, and I'll show you that second option, but I'm going to show you the first option first. So the x squared minus 9, that's actually the difference of squares pattern. So I'm going to factor it as x plus 3, x minus 3. That's how the difference of squares patterns works. It's a good one to know. And then this one is also difference of squares, so I can factor it as x plus 2, x minus 2. And then that's equal to 0. So I can take every single one of these and set them equal to 0. So x equals, if I set this one equal to 0, I get negative 3. If I set the second one equal to 0, I get 3. This one gives me negative 2, and this one gives me positive 2. Okay, so that's one option. You can totally factor it down completely, or, like I said, the second option is to go from here. If I went from here, I could set both of these equal to 0. And then here we'd add 9 to both sides. Here we'd add 4 to both sides. Then the last step is to square root. So when I square root, I always have a plus or minus. So here I'd have a plus or minus 3. And here I'd have a plus or minus 2. So it's not, one's not really shorter than the other necessarily. It's, I guess, kind of whatever your preference is. If you're prone to forgetting your plus or minus, you might want to do it this way. If you're really good at doing all this, the factoring and the square rooting, you might want to do it this way. But either way, you end up with the same 4 answers, and those 4 answers are letter A. Okay, synthetic substitution to find f of 3. So my function, I've got x squared, is this, and then minus 9x plus 5. they're asking me to find f of 3. So this is a little weird because the synthetic division, you always put the opposite of the factor in the little bracket. When I want f of 3, that means I put 3 right into my little box. So make sure you're clear on which scenario you use the opposite of what you see and what scenario you use exactly what you see. In synthetic substitution, like this, you use exactly what you see. Same process though. The 1 comes down, I multiply 1 times 3, put that right here, add these two together, it gives me -6. -6 times 3 gives me a -18, and then I'm going to add these two together, and that leaves me with -13. So the remainder that I get, that's actually my answer. That's f of 3. It's exactly what I would get if I would plug 3 into my equation directly. So that's letter H. Okay, one factor of this cubic function right here is x plus 2. Find the remaining factors. So I know based on my degree that I'm going to have 3 factors. I just need to find them. So the way that I find them is by doing synthetic division. We're getting lots and lots of practice with that. So I'm going to take this 1x cubed, 4x squared, -11x, -30, and I'm going to divide by x plus 2. This is the situation where I would go with the opposite of what I see. Since I'm dividing by a whole factor, I put the opposite of that number in the box. 2 totally separate scenarios here that are both using synthetic division. Same process though. So multiply these two together and I get a -2. Add these two together and it leaves me with 2. Multiply 2 times -2 and I get -4. When I add these, it gives me -15. And finally, multiply these two together and I get 30. I'm supposed to get a remainder of 0 with these type of problems. When it does the here's the polynomial, here's one of the factors, find the remaining factors. Because I got to take this, write it as a new polynomial. So I have 1x squared. This drops to an x squared because this was an x cubed. So it always drops down 1. Then plus 2x minus 15. I'm going to factor this down. So right now, I have this as a large factor. This is another factor. I can factor this down even further, and I'll get these 2 factors. So I know I'm going to have x times x. I need to multiply to -15 and add to 2. So that would be a +5 and a -3. So those are my other 2 factors, the x plus 5 and the x minus 3. All right, so that would be letter B. Number 18. Which describes the number and type of roots of this equation right here. Okay, so this equation is a line. Nice, neat line. It technically has a degree of 1. If I have a degree of 1, I can only possibly have one answer. So letter G is out, letter H is out. And this is a line. We know what lines look like. Lines don't have imaginary answers. The only type that have imaginary answers are like second power functions, second degree functions, third degree functions. This couldn't possibly have imaginary zeros. So first of all, the letter is J, just kind of going off intuition, but we could always solve the equation. And if I divide both sides by 4, I get an answer of x equals -7/4. So you can see right there I come up with one real answer. It's definitely not imaginary. Okay, number 19. What is not a root of this equation? So I know that since this is multiple choice, it'd be pretty easy to just plug these in and test them out. We're not going to do that. We're going to pretend as if I gave you this problem without a multiple choice because nothing on your test will be multiple choice. So we're going to walk through exactly how you would find this. And number 19 and number 20 are the same type of problem. All right, so we start by doing like the P's and Q's. So P's are all the factors of the constant term, which is 8. So my factors of 8 are 1, 2, 4, and 8. And it doesn't matter that this is negative because I'm going to have the plus or minus in a couple steps anyways. And then Q is all the factors of the leading term, which is technically 1. So 1 is the only factor. So when I do my P over Q, all I have to do is put them over 1. So P over Q is always just P over 1, since Q is always 1. So it's just the P's. So plus or minus 1, plus or minus 2, 4, and 8. So I have 8 possibilities. All right, 8 possibilities for these zeros. The next thing that I do is I do my counting thing, my sign changes. So like here, I see there's 1 sign change. So that means I'm going to have 1 positive answer for sure. So I'm going to use that fact and I'm going to go with it. So what you would do is you'd test out, test out the 1, test out the 2. So I've got some space here. So we're going to test out positive 1. try to do synthetic substitution. So 1, -1, -10, and -8. Bring down the 1. When I multiply here, I just get 1. When I add, I get 0. When I multiply, I still get 0. Adding gives me -10. And then multiplying gives me -10. So because I come up with -18, this is not a 0 of my function. I should get 0 here. So I'll test the next positive answer, which is a 2. Okay, so same process. We've done this so many times so far, even just in this video. Multiply, I get 2. Adding gives me 1. Multiplying gives me 2. Adding gives me -8. Multiplying gives me -16. And unfortunately, adding gives me -24, which means that the 2 is not my answer either. So I only have 2 more options. It's got to be either the 4 or the 8. So let's just keep going in order. So bring down the 1. Multiply, I get 4. Add these together, I get 3. Multiplying gives me 12. I add, I get 2. Multiplying gives me 8. There we go. Okay, so 4 is one of my answers for sure. And then what I do is I take this and I write it as a new polynomial. So since my degree was 3, drop it down to 2 plus 3x plus 2. And I want to factor that down. So what multiplies to 2 and adds to 3, that would be plus 2 plus 1. So my answers are the 4 that I found using synthetic substitution, and then when I solve this I get -2, when I solve this I get -1. So those are my 3 answers. The way the multiple choice is worded is what is not a root, and that would be letter A. +1 is not one of the roots. I'm sorry, +1 is not one of the roots. Okay, so just one more, number 20. Same type of problem. And then the bonus, of course. So find all the rational zeros. So we're doing basically the same thing. It's worded in a slightly different way, but we're still doing the P's and Q's and the sign changes and things like that. So the P's are all the factors of 16. Again, doesn't matter that that's negative. So you've got 1 and 2, 4, 8, and 16. Those are all the factors of 16. You can always check to make sure that the pairs are there, like 1 times 16, 2 times 8, and 4 times 4. And then Q, again, is just a 1. So we're kind of lucking out with these here. So P over Q is really just P. So all of my options are plus or minus 1, 2, 4, 8, and 16. So I technically have 10 options here. So I'm going to do the same thing that I did with the previous problem. I want to point myself in a good direction. I want to know if I should go in the negative direction or if I should go in the positive direction. So count our sign changes. I have 1 sign change here, which means I definitely have a positive solution. Okay? So I have 1 positive solution for sure. And so now let's test out the positive solutions. So same process as before. I will tell you, I'm just going to kind of push you in the right direction here. You could test out the 1, it won't work. You can test out the 2, it won't work. So let's jump right to the 4. Of course, this is trial and error for you guys, but you've seen synthetic substitution so many times, I think we know what we're looking at by now. 1x cubed, careful here, 0x squared. If you're missing a term up here, you use a 0 as a placeholder. Negative 12x and then minus 16. So bring down the 1. 4 times 1 is 4. Add these together, I get 4. 4 times 4 is 16. Add these together, I get 4. And then 4 times 4 again is 16. So this leaves me with a remainder of 0. So what I did last time, remember you take these, you write them as a new polynomial. And my power is going to drop down 1. So that's my new polynomial. And then I can factor it down to find the rest of my zeros. Okay, so I do x times x. And then what multiplies to 4 and adds to 4? That would be a positive 2 and a positive 2, which I could also write as x plus 2 squared. So when I set that equal to 0, I end up with an x equals negative 2. So this technically counts as 2 roots because I've got 2 factors right here. It's something called a double root, which you'll talk more about in pre-calc, not super important now. But we have the 4 that I came up with here, and then the negative 2 that I came up with here. All right, so that is letter F from the multiple choice. Very last problem of the review, this bonus question. All right, find the value of k so that x minus 3 divides, all right, so we've got 2x cubed, negative 11x squared, 19x, and then a k. Okay, so we want to divide by x minus 3. The fact that we're dividing by x minus 3 means we're going to put a positive 3 in the box. Okay, so we want to get no remainder. So this is the bonus part. So bring the first term down. Bring down the 2. 2 times 3 is 6. When I add these together, I get negative 5. Negative 5 times 3 is a negative 15. Add these together, I get 4. 4 times 3 is 12. All right, so if I want to get 0, that means that k combined with 12 has to give me 0. So that means that k should be negative 12. Okay, so that was definitely a tricky bonus. All right, so that's the last one. Review is all done.